In previous videos, we've explored how cone material affects the response of dome tweeters and a 6-inch driver. In this video, we're going to explore how the geometry of a speaker cone affects the driver's response. We'll compare 3 cones, each with a different shape and expansion profile. Speaker cones come in various designs. Some have straight conical walls, others feature curved profiles, and some vary in height. But the real question is, does the geometry actually impact the frequency response? Let's find out. This time, we're testing a 5-inch woofer to see how its geometry impacts performance. Here's the original shape of the cone. First, we reduce the cone height. To do this, we use AB Viewer, a lightweight CAD software, and simply adjust the cone height on the speaker's plane. This plan is provided by the simulation software designers. Before making any modifications, we create a backup file to ensure we can revert if needed. Next, we adjust the cone geometry to analyze its effects. The software then generates a 3D model based on this 2D plan, allowing us to visualize and compare the This change has no significant impact on either the frequency response or the directivity plot. In our horn design videos, we created an Excel tool to generate horn side profiles. So, what happens if the cone expands like a horn? We treat the voice coil as the horn throat and expand the cone in a horn-like shape. To properly shape the horn flare, we define key points along its expansion. In this case, we're using a spherical horn with a cutoff frequency of 1450 Hz. The software divides the cone into multiple sections rather than treating it as a single unit. This likely helps simulate cone breakup more accurately by capturing how different parts of the cone vibrate independently. As you can see, the horn-shaped cone has been successfully implemented. Choosing a high-damping material helps reduce unwanted peaks and results in a smoother response. Paper pulp is a great option for this purpose. Paper pulp is widely used in practice due to its low cost and well-balanced acoustic properties. Once again, the simulation shows no major differences in response. While there's more to explore regarding cone geometry, in this case, the differences are minimal. Thanks for watching.